Welcome to Brain Vision.
It's all about partial derivatives. This section is about using partial derivatives to create some approximations. And so we have a model for the surface area of a human body, which is given by 0.1091 times the weight to the power of 0.425 times the height, 0.7 to the power of 0.725. Where W is weight in pounds and height is in inches. But S is in square feet, so you have like an inch to feet sort of thing happening in case you wanted to find out your surface area. So to do this, we're going to take this equation and differentiate both sides with respect to S. Okay, so we do that, and S, taking the derivative with respect to S, gives us a 1. So this thing on the right gets suddenly more complicated. That's going to give us a 0.1091. And we use the product rule to separate this a little bit. So this is going to be h to the power of 0.725 times w to the power of 0.425 with respect to s, plus then w to the power of 0.425 times h to the power of 0.725. The derivative of h with respect to s. Okay, now we are going to use the chain rule to rewrite this right-hand side. So we get 0.1091 h to the power of 0.725 times w, the derivative of w with respect to w, so w to the power of 0.425 times w with the derivative of w with respect to s. And then we'll do a similar thing here where we take w to the power of 0.425 times, and take the derivative with respect to h times, of h to the power of 0.725. These multi-decimal powers are not the most fun to write, and we'll have the derivative of h, or take the derivative with respect to s of h. Okie dokie, it's getting worse to write. But now we'll use the power rule to actually differentiate. Okay, so this is 0.1091 times h to the power of 0.725 times 0.425 w to the power of 0.425 minus 1 times dw ds plus w to the power of 0.425 times 0.725 times h to the power of 0.725 minus 1 times dh ds. Okay. So we're actually going to just, instead of adding these together, we're going to separate them and pull out like a 1 over w or a 1 over h, and then otherwise kind of leave them the same. So it might look a little weird. I mean, I think the instinct is to make that little calculation, but we're not going to do that. We're going rogue, but not rogue, we're going calculus. So it's h to the power of 0.725 times this 0.425 w. And I'm going to leave it to the power of 0.425. And we're handling that -1 by having a 1 over w here. Right, and then we'll multiply that this way. We're going to do the same trick with the other expressions. So w to the power of 0.425. And then multiply that by 0.725h to the power of 0.725. But then we got a 1 over h times this dh ds. Okay. I haven't been writing it, but there's a 1 on this left-hand side. We'll think about that again someday. Okay, so then we have 0.1091. And then we can just kind of move some stuff together so it's not quite so horrible to write, but it's still kind of horrible to write. 0.425 w to the power of 0.425 times h to the power of 0.725 times 1 over w dw ds plus 0.725 w to the power of 0.425 h to the power of 0.725 times 1 over h dh ds. All right, cruising here. So now if you recall from our original equation, we had s is equal to 0.1091 times this w to the power of 0.425 h to the power of 0.725. So we're going to substitute that in, right? Because we can see that in here. Since we have here's the w's and h's, and then the 0.1091 on the outside. Okay, so we're just going to replace those with s, and that gives us, we have 1 is equal to 0.425 s ds times 1 over w dw plus 0.725 s ds times dh divided by h. Okay. So if we multiply everything by ds over s, we get 1 over s ds on the left-hand side. So finally that 1 comes back into play. But then these expressions will disappear nicely. So we get 0.425 1 over w dw plus 0.725 1 over h dh. Well, so we can use this then. This tells us, that delta S over S will be approximately equal to then 0.425 delta W over W plus 0.725 delta H over H. And since the errors of W and H are at most 2%, then we know that delta W and over W and delta H over H are at most equal to 0.2. Oh, sorry, that would be 20%. 0.02 is going to give us our 2%. So that means, the maximum area here in the surface area must be less than or equal to 0.425 times 0.02 plus 0.725 times 0.02. And this means it must be less than or equal to 0.023, which is also equal to 2.3%. Okay, so that's our final answer.